tell me from where you need to
Ma'am, can we
study it.
start? Because as soon as you share the screen, uh,
Okay, can you see
I'll get
now?
it done. Yes, ma'am.
Okay, so we have done the formula like on Laplacian formula. Have you done that?
Yes, ma'am.
Yes, Laplacian formula, and we here we are doing question based on it on in
Yes, ma'am.
exercise on page number
Yes, ma'am.
24, and this is the formula, and we need to find this del square tx means we need to just differentiate twice with respect to x, and similarly with respect to y here, with respect to z here. Okay, we have ta means value of t means function is given, and we need to just multiply first. So differentiate with respect to x one time. This is the result. Got it?
Okay. Yes, ma'am.
And then differentiate it again with respect to x similarly. So we have here 2 only because this is 0 with respect to x.
Yes, ma'am.
Now differentiate with respect to y. We have here
Okay.
0 with respect to y. We have here 2x, and here we have zeros. Okay. Then
Yes,
differentiate it again with respect to y. We have 0 here because here only one term of x. So second order is 0 with respect to y. Similarly to with respect to z, we got this 0 for this term, and this for this term also, and 3z will become 3, and 4 is 0.
okay, ma'am.
So tz is del tz is 0 0 plus 3 plus 0, and we have here 3, and second order derivative will become 0. Got
Yes,
it?
ma'am.
Because yeah. So now put the all values of these terms here. Okay, so value of this second order with respect to z is this 2, and these both are zeros, you know, we have found. So put a
Okay.
0, and so we have this. Okay, Laplacian of ta is, we have ta, so this is what Laplacian of ta. Okay,
Okay, ma'am.
and you can do the same next question in similar way.
Okay.
And so let us understand the next topic. Or shall I, or do you want to ask anything?
No, ma'am. Ma'am, we can move ahead.
Okay. Okay. So next, let us learn line, surface, and volume integral.
Okay, ma'am.
Okay, line, surface, and line along means it can be as a horizontal or vertical. So we take only one dimension. Okay. So we
Okay.
will apply only one limit from origin to any other point, length
Okay.
of that line. And second, in surface we'll take two dimensional. Okay, then we'll apply two
Okay.
limits like as a Cartesian plane by taking x-axis and y-axis. And similarly we'll find if we'll find the volume integral, then we'll apply three limits because this is solid and we need 3D shape to
Okay,
find
ma'am.
volume. Are you getting this point?
Yes, ma'am.
Okay. So on page number 24, see a line integral. A line
Yes,
integral
ma'am.
is expressed as the form of a limit a to b in vector this v into di. What is di?
Okay, ma'am.
Di is uh, along with this position so, vector. Okay, as I'm explaining you. To into this x bar plus dy into y bar, sorry, x cap, y cap, and z cap, sorry. So this is dA use. Okay.
Okay.
So this is the formula on page 4 of line integral.
Okay, ma'am.
Yes. And see the example here. Example 1.6, calculate the line integral of the function b is equal to function is given and at point a to b. Uh, if we have points, example 1.6, see, we have
Yes, ma'am.
function v is equal to y square x cap plus 2x y plus 1 into y cap, and we have the points
Yes, ma'am.
a is 1 1 and 0, 2 point b is equal to 2 comma 2 0. Okay, if we apply line integral, then we take only these first to this first value. As you know, this is x means along horizontal path for line integral. Okay, so we'll
Yes,
take
ma'am.
only this one dimensional. So we'll take along, you can say, x axis only.
Okay.
Yeah. So this is value of x, y. See, this is value of x, and here also. So we'll take only these values.
Okay, ma'am.
Are you getting this? Are you
Yes, ma'am.
getting
Ma'am, we
this?
can take either X, Y, either of the two we can take, right? Or is it
Yes.
compulsory that you have to take only X axis?
No, no. You can take either.
So,
Okay.
ma'am, this question
Any
can
one of
also
them.
be solved if I take Y axis.
Yes.
Okay.
So let's do this. Hmm. So if you are choosing this x-axis, then take dy and dz is equal to 0 because we are not taking this y and z. Okay. So if
Okay.
you are taking this, and if you are choosing dy, then take dz and dx 0.
Okay.
Okay.
Yes, ma'am.
So for line integral, di is equal to, dx into x cap plus dy into y cap. Here we are using this formula. But here on horizontal line, we'll have these two terms 0. So we are taking only this term.
Yes, ma'am.
For line integral and along or for horizontal line case. Or for horizontal line. We are using this. So let first term having this x cap of the function,
Okay, ma'am.
this, we have y square. This is y square. Let me write a little bit more clear. Because when we multiply this with this, we'll
Yes, ma'am.
get 0. Okay.
Okay.
So integration of v and di is equal to, we have, and here we are using limit, and we have y square,
Okay.
and first term of this is x cap, and x cap we have here this also, and x cap into x cap is equal to 1.
Ma'am,
You
I
know
have
that?
a doubt.
Yes,
Uh,
ask.
how exactly did we get y square?
Yeah.
Ma'am, how did you? Oh, y square is the first term. Oh,
Yes.
never mind. Yes, ma'am.
Yes.
I understood.
Yes. Yeah. And this product of dot product of this, or you can say I dot I is equal to
Yes, ma'am.
1. Yes. And if you multiply I into j, means first term to second term, then we'll get 0. That is
Yes, ma'am.
why we'll take only this term.
Okay.
So we have here integration of y square with respect to x, and this 1 second, I'm just checking. They are giving y is equal to 1 here.
Okay, ma'am.
Let me check. Give me 1 minute. I'm just uh,
Yes.
checking one thing. Okay. See, here,
Yes, ma'am.
see a point. See, initially we have point, A 110. We have value of x is equal to 1 initially and y also equal to 1. And at B, we have here x is equal to 2 and y also 2 and z is 0 in both cases.
Yes, ma'am.
Okay, so we need to find for both. Okay, as a
Okay.
horizontally and vertically. So initially we are taking here in first condition, means because we are integrating with respect to x, so we need to put the value of y here. Okay,
Okay, ma'am.
so we can take here in initial this y is equal to 1. That is why they are taking y is equal to 1 here. Let us put here.
Okay.
Put y is equal to 1. Then we have integration of v into di is equal to integration of 1 square here. So we have here we can write as 1 to 2 dx only.
Yes, ma'am.
But yeah, so let us find. We have here x and upper limit and lower limit, and we just apply the limit. You know this,
Yes, ma'am.
obviously you know. Yeah, so we have here 1 along x-axis. Now change the position and stretch along the y-axis, or you can say vertical stretch
Okay,
this
ma'am.
line. So here di will take as dy into y cap, and
Yes, ma'am.
now position is changed, so we'll take this point. Okay, so here
Yes.
because take now terms v into di is equal to integration of dy and y cap, and take the term having this of v, which is 2x and y plus 1 into y cap. So y cap into y cap will become 1, And let us take the rest of integration of 2x and y plus 1 in dy. And now position is changed. So now we are integrating with respect to y. So just put
Yes,
value
ma'am.
of x. So from now this is the second position. So take
Okay.
x here, x is equal to 2. So we have this integration of v di is equal to 2 into 2 and take this y plus 1 and integration 1 to 2 because our position is changed by 1 to 2 by using a value of 1, sorry, a and b
Okay,
of
ma'am.
y. So here we have 4 and y plus 1 dy having limit 1 to 2 and take this 4 and now integrate this y plus 1. We have y square by 2 plus y.
Okay, ma'am.
Okay. So now just apply the limit. So upper limit 2 square by 2 plus 2 minus 1 square by 2 minus 1. So
Yes, ma'am.
this is 4 and here 2 only plus 2 and 2 minus 1. So 4 into we have 3 minus 1 by 2 and we have 4 into 5 by 2. So this is done. This integration of VDI. So we have this complete in along x and y, means along horizontal and vertical. We have this complete a to b v d v I. Sorry, v
Yes, ma'am.
di is equal to. We'll add this along this horizontal we have here and just add with vertical position,
Okay, ma'am.
which is 11.
Yes, ma'am.
Okay. Mm. And tomorrow we learn surface integral and volume integral. Okay.
Yes,
I
ma'am.
think we have only, let me check how many topics are left in this chapter. Mm, yes, we have surface and volume integral only. After that, we'll start the next chapter.
Okay, ma'am.
So let's do next day. We'll finish.
Okay, ma'am.
Okay, and just check the first chapter. If you have any problem, then I'll explain you about of first chapter. Okay.
Yes, ma'am. I will.
Uh,
Thank
okay.
you, ma'am.
And if you face any, yeah, you're welcome.